Everybody, and thank you for attending this. We are trying to organize a series of webinars to support you in the design challenge, and this one is the last one of the season. So we finished the regional event, and now is time for you to get ready for the national in October. So welcome. Congratulations for all your effort, and I hope that you'll find this set of chat and slides useful. There is a Q&A button at the top. We may not be able to answer all the questions immediately during the webinar, but we'll answer in due course. Thank you very much again. Next slide, please. So, well done. You won the regional. I hope that you had fun in all the process, and then let's try now to have even more fun and to get ready for the national. The national competition will put you probably in a different condition, in a position where you will meet other people. You will be at the headquarters of the IMechE in London, and you will showcase your product and your project to a lot of other people. So it's going to be a great day for you. Hopefully you'll manage to improve what you've already done and get even better results. The scores at the final tend to be quite close, so it will be tough, but it will be fun. Next, please. So there are a number of elements that you have that you explore with the design challenge, and they're all engineering concepts that you will be exposed to in your career. So the first one is that the verification. What means verification is proof that you meet your requirement. Fundamental is that you read the regulation and you say that you can design something that fits for the purpose. Then the validation is that is a second step. So you prove that the requirements were accurate. So my product, as is built, will do the job that was written in the regulations. There are two other aspects that are very, very important on the life of designing and developing products, which is durability, which is the design and the product that you're putting together will survive a number of cycles in a standardized condition. Now, those are all your tests, all your events, and especially the hits and the final. Very, very important, where students sometimes not get exposure to this, is the concept of robustness. Robustness means my vehicle will perform and will survive in any possible condition. It means I don't have a very robust product, means that you don't have to have a specific operator to run it. You don't need a specific surface to run it. It will always perform at the same way, regardless of time of the day, humidity, light condition, all this kind of stuff. To give an example of a very robust product and a relatively less robust product, a normal passenger car, let's say a city car. A city car could be used in any road or of any city by any driver that has basic skills, while a Formula One car is used only by a specific set of drivers, and it will go only on bespoke circuits. So the robustness of a Formula One car is much, much lower than the robustness of a city car, if you know if you understand what robustness means. Something that we often get involved in are questions about the tolerance of the flatness, the different color of the surface, the different shade of the printing target, and so on. So all of these things are clearly listed in the regulation and are a test for the robustness of your product. Next, please. So there is, now that you have a product that is working and you have submitted once all your electronic files, for the final it will be the same process, but you have done some tests, you got the final result, and the recommendation is to spend some time in where the area that you should improve. So, for example, ensure that you got enough time to test and your vehicle will still perform, will still behave without being affected by battery charge or all these kind of things. The other one is try to increase the accuracy of the vehicle. Every team will work on the accuracy to get better scores, to bridge that little gap that may have gone not as planned during the regionals. Something quite important, most of you will travel far away from where the location is. Put your time in securing a nice padded box or transport case. You will be surprised how many damage happen to otherwise a perfect vehicle just because of the transport aspect of the event. Next, please. One of the aspects of the design challenge is pushing the student to work to set of regulations. So regulation could be what is a brief of a project, or regulation could be a large set of data that you need to comply to if you're tendering for a large project. So there are a number of things that will be relevant to you when you talk about regulation. So some aspects, but not all of them are here, are a registration done on time and a complete submission of all the electronic files done on time on the portal. Ensure that all the vehicle is done following all the rules that are listed. So there is a single battery with a single wire and a single fuse. There are no exposed electrical joint, including any element of Arduino, Raspberry, or any other programmable electronics. There is no risk for finger trapping. So all the safety aspects have been checked and have been analyzed. It means that you have thought about your product as if you were designing and then get into production for any type of customer. Something quite important, and that could create issues both to the functionality of the vehicle or to the safety of the vehicle, is ensuring that there is no cable, wiring, or any other stuff that could interfere with the transmission organs, including wheels, so nothing rubbing against each other. So think about all the little things that could go wrong and all the little things that are listed where the vehicle will be scrutinized. Next, please. Something which is we think useful is if the students familiarize through the regulation with the scoring criteria. So all the specifications list how the competition will be scored. So you could familiarize on all these aspects. And you can actually use your scoring tables as a checklist. So you could look at your device, look at your submission before you do that one and say, right, I'm going to be scored on these. Did I achieve this level? Tick in the box. Did I achieve that one? Tick in the box. Oh, I cannot achieve this because I don't have time, or I don't have the skills, or it's just beyond the scope of what is allowed to do at university. Fantastic. You know that you are not going to tick that box. So just try to be familiar with how the vehicles and the contenders will be scored. Overall, please remember that there are two key aspects to this competition. So one is that the physical element of the competition will consist of 60% of your score. So is a large chunk that takes your score there. However, you cannot become the overall winner if you have not done all the other electronic submissions. So if your vehicle is perfect, you score always 100%, but you have not submitted for all the CAD and all the other stuff, you may win the physical competition, but you will not be crowned overall winner because you have not done all the other elements as a submission. So I would like to point you to why all the other elements are important of the electronic submission. At very, very high level, the presentation, so the video presentation submitted electronically, is a proof that you could engage with your customers. So imagine that you're launching an advert for somebody, and that you can engage with the marketing people and the new sales people of the company that want to buy your project. The poster is quite important. Imagine that you're trying to gather a budget from the senior manager in the company that want to produce your stuff. So the poster needs to be compelling, clear, telling clearly what the device does, how it's built, and how much it will cost. That is why that is important. Then you have the electronic element of the CAD and the BOM element. That is where you need to win the trust of the hardcore engineers that will scrutinize your device before really signing off you as a winner to put in production something. The physical element of the competition is the proof in front of the marketing people and your customer that your product really does what you declared. So you're really convincing them that your product is doing a good job. So all those elements, although they may feel a little bit too much, have a different meaning, and the meaning that you could transpose in your real life whenever you will finish university and you will go to work outside in an industrial environment. Next, please. There are a number of elements into the design challenge, and one which is quite important, and sometimes it gets a little bit not thought about, is that the device has a fixed time given regardless of the length of the track. What it means is that the better way to define your vehicle to do a good performance is to test it as much as possible on the long track, because the one where the device will consume more energy will potentially be affected more by the alignment and other conditions. So if you manage to score high on the long track, highly likely when you do your test on the medium and the short track, you will perform equally well. Next, please. As a part of the design challenge, sometimes we receive suggestion or request to suggest a good split of time. We are aware that all the students are involved in a lot of tasks, including the design challenge. Some of you will do this as an extracurricular activity, which again is getting that time and that planning. The time schedule and the time split that we are listing here is not the only way you can plan your activity, but we feel is a good starting point to organize your activities and try to split and try to keep track on how much you need to spend on those tasks. So whenever you will receive this video and the slide pack separately, we suggest you to try to have a look and see if you feel comfortable and happy with what we propose here as a split to achieve a good final result. Next, please. Please be mindful that there are a number of penalties that are listed in the regulations. So some penalties are relatively clear, and they're about late submissions. Late submissions will be considered pretty much as being over budget. The reason is that if you get more time, you get more time to refine something that other team didn't have the opportunity to do so. Going over budget again will be treated in the same way. So you get a target. If you go over, fundamentally your product is too expensive to be built. There are other elements please be mindful of. So if the plunger is too large, you will be penalized because it puts in a condition where you hit easily the target. If the datum pointer is the wrong position from the ground, the judge may have difficulties in scoring your stuff. So again, is a requirement, and you could be penalized on that one. If the plunger on the advanced category, if the plunger does not realign or move, there is a specific penalty over there. So try to be mindful, check how much of this penalty is here, and if for any reason you have a struggle of the last second, assume that that will be a potential for a reduction in the point that you gather. Next, please. There are other elements, and so far it happened only once to disqualify a team. So it's possible on this type of competition that one device will go off track and could interfere with others. If that happens, basically you will be disqualified. If there is no submission or an incomplete submission, again, you will not be allowed to accumulate all the points as for the overall winner. Clearly, if there is no submission, it will be difficult to sustain you for doing the physical element of the competition. Please ensure that you do electronic submission on time. If the device with the programmable electronic is programmed outside the allowed time or has any Wi-Fi connectivity and you do live programming, that will be, again, a disqualification immediate. It will be considered an unfair technical advantage. And if the device is too big, it doesn't fit in the envelope, that will be outside the scope of the regulation. So again, it will not be allowed to compete. So please be mindful that on top of those, there are other ones that we already talked about risks like finger trapping, absence of the fuse, multiple battery packs, and so on. So please spend your time in familiarizing with the regulation, what could go wrong. Next, please. There are a number of appendix with a checklist and list of elements that you could look into. And we thought that it was a nice thing to allow you to organize your submission, all the other stuff. Please remember that those checklists are there to help you and not to do a tick box exercise. So one very important is the checklist for the academic or institution supervisor. It really asks for your supervisor, lecturer, or whoever is taking you to the competition to inspect the vehicle for safety, inspect the device for accuracy with all the regulations, presence of any safety element, protection, and all those aspects. So please be mindful that all those elements that we have included are to help you and to try to ensure that everybody's going to have fun and everybody's going to compete on a plane and an even field. Thank you. Next, please. Very, very important. Whenever you check your items, and clearly this is down to the team members and not to the lecturer, are you confident that your vehicle look like the CAD that you submitted and will perform as it is shown in all your presentation and all your calculation that you may have associated? Is your documentation clear? And the bill of material is quite comprehensive and clear. So whatever we see there is a good representation of the cost that it may be required to build this vehicle. Does the poster show the vehicle as it is in reality? So it's a good representation of the reality. Does it include indications of how much is the total cost versus the IMechE cost? Does it show the mass of the vehicle so that people could understand how big is the element? Does your presentation show how you get to the final design? So what were the ideas, the concepts, the steps that you evaluated, and how you eventually got to the final design and the final journey? That is to build up that falling in love moment between the customer that is looking at your presentation and your final product. So please try to pay attention to those details and try to, at the same time, be proud of what you have done. So present positively all the hard work that you have achieved in a way that everybody could understand quickly and going straight to the point. Next, please. I will now hand over to our representative from the industry that will chat about ANSYS.
Davide, thank you very much. And I was taking notes as you were going through that. Hello, everyone. I'm going to be talking about the ANSYS Simulation Challenge. So first of all, congratulations to the teams who are here. So you have come through the regionals, you've won, and now you're on the final stretch. And this final stretch is really about improvement. It's where you are now and how can you get even better. And you are competing against the best of the best to be the best. So we all need to up our game. And this challenge is open actually now only to those who are going through to the finals because, well, you're already winners in some sense. We want to see how far we can push this with you. So if you go on to the next slide, I will start off really about talking about why ANSYS is doing this. Why are we here? Why are we talking about simulation? Why are we asking you to do a little bit more? And the slide I'm showing here is the vision that we have as a company for this idea of the digital transformation and the fact that it can lead to companies having up to 0 physical prototypes. So that means in the company that you work in or the company that you start, the first time you build a device is the last time you build it. You build it once and it's done. And this is really important because it saves time, it saves money, it saves resources. And in a world where we have things like trade tariffs and trade wars and shifting resources from one country to another is getting harder and harder, being able to do more with less physical resources will be an absolute game changer. So this digital thread, designing in the digital world from the very beginning of your idea, right until the end, right to before the product is built, that's the future. And it also allows you to assess across that entire thread, the things like the ecological impacts, the material selection, how that affects the design. You can do it all in the digital space. And like I said, it saves time and it reduces time for development. You get validation much faster for very complex systems. You can reduce the weight of devices, you use less resources. Basically, it's the way the world wants to go. And by getting involved in this challenge, you can get a head start in learning about simulation. Can I have the next slide, please? Now, more and more companies are going in this direction, as you will see if you just hit through the animations there. So currently, estimates are that about 60% of engineers in the top engineering companies use simulation. And I've seen companies, even till now, they're realizing they need to get on board with this. And the projection is that in just a few years, at the top companies, all engineers, all design engineers will need to know simulation and be able to utilize it to, like I said, reduce time, reduce cost, and reduce resources used. And in the next animation, you will see the industries where this is already working out. Everything from aerospace to construction, energy, even healthcare. There is so much simulation going on in healthcare you would not believe. I have seen a simulated model of a human heart, and it's all happening. All right, next slide, please, Dominique. So what are we asking you to do? And the idea here for the simulation challenge is really to make it very easy for you. I know you have, like Davide mentioned, you have a number of digital submissions you need to make. And this is meant to sit really alongside your design process. So you've come from the regionals to the finals, you're looking to improve. Here's where simulation can really help. What is it you want to change? Is there something you want to optimize in your design? Make it lighter, make it more robust. That's the kind of thing we're looking for. And your submission is really simple. It's a slide or two. And it's just putting together, this is the model, this is what we set up in simulation. These are our estimations, our assumptions, and then a 3-minute video maximum. And this would look like just a screenshot, a screen grab of someone talking through the simulation. Here's how it was set up. Here are the results. Here's what they mean. And you submit it at the same time that you submit the other things that you're sending in for your design challenge. Everything is available on the website. You could go back just one more, Dominic, just to point out the scoring there. So everything is available on the website. And like Davide mentioned earlier, the scoring is available for the main challenge. For the simulation challenge, you can see what's important as well. The most important thing here you can see is understanding how to set up this problem. What are the boundary conditions? Have you set up the analysis properly? The next most important thing is, how do you interpret the results? So I know a number of you maybe have seen simulation happen. You've seen images, you've seen videos, and you can get some really pretty colors coming out of it, and that's fun. But what does it actually mean? How does that then define your design going forward? And that's very important. What does that do for your design? How has it helped you? Now, the prize we've mentioned here is you get free ANSYS simulation certification and be featured in the blog. Right now, it means you might not know what that looks like, but the last few slides I have will show you exactly what that is. Can we go on to the next slide, please? All right, so a few more details about this. Like we said, the deadline is the same thing as the general challenge. We need you to register for this so we know the teams who are going to participate. And there's a code below. Dominique, will these slides get sent out later?
Yes, they will.
Okay, great. So you can find it here. You can get it. And the simulation, it depends. So the rules will stay pretty much the same for whatever device is being done each year. And we're making it flexible so that your simulation could be either a structural, a thermal, or a fluid simulation. You don't have to do a very complicated dynamic simulation of your device moving. If you want to, that's fine. That's a bit more complicated, but that's not necessary. But just choose a component and do some analysis on it and improve its performance by lightweighting, while maintaining the structural integrity. A model analysis, a fluids analysis, a thermal analysis, any of these are applicable. As long as you can show how it has been used to improve your design, then that's what's important. Can you go on to the next slide? Okay, great. So a bit more information. For this, we'd love you to use ANSYS simulation. And we have loads of resources that are available. And if you want the software, you can get it for free. And the QR code is just there as well. So get the software for free. If you need some training, if it's something you want to learn, you're not familiar with it, you can get loads of content over there. Dominic, thank you so much for these QR codes. There's loads available. And this is really quite, what you're doing here is not really complicated. Taking one element won't be that hard for you to do, but also it's a skill that would serve you very well in the future. All right, could you go on to the next slide? All right, so what we've got here, and I don't think we can show it unless, Dominic, you're able to click on that just to quickly show. There's an example that you can find on YouTube of what a simulation, and this one is a structural analysis of the hook that's used for one of the previous devices. And it's just an idea of what you could do and what you could submit. Just a quick simulation of what you could do there. So that's a really good resource for you to have a look at and see what you can do. And this was done in a few minutes. It's not that hard, but the understanding behind it and the skill that you are developing, that's what we're really interested in pushing you, if that's the word, pushing you to get to do. And like I said, you can view that on YouTube there. It's available for you there. Okay, next slide, please, Dominic. Okay, so what can you get out of it? So here we are asking you to do this thing, to do, do some simulation, which will take some extra work. And then, send in a couple of slides and send in a short video. What's in it for you? For one thing, you will have a skill that companies are looking for right now. So that's for you. You will have that. But also what we've done, so this was a team that won the simulation challenge last year. And this is a blog we did about them on the ANSYS website. Now you could put this in your portfolio. Even if you don't win, by the way, even if you didn't win the challenge, you can take your simulation, put it in your portfolio and let your future employer have a look at it and see what you've done. But for the winners, this is what we would do. We have a blog, we interviewed them. There are a few more details. This is on the ANSYS website right now. You can just Google ANSYS Design Challenge and you will find that. And we talk about them and their journey and what they've done. And you can share this. You can share this if you're going for, an interview, for an internship or a full-time position, or if you're looking for funding for a company that you have started, you can say, hey, look at the kind of thing that I've been involved in and I've been successful with. So this is a really great opportunity for you to be celebrated in the bigger engineering world. And the next slide, please. And I mentioned certifications. Now, at ANSYS, we have some resources, some learning tracks that you can go through that are available online. And each of those comes with a certification. It's a proof that you are able to do simulation. And these typically we sell, they are available for about £330 each. But we will give this to every team member from the winning team. Now, this is valuable to you because this goes on your CV. This can go on LinkedIn. And we have found from our research, and you would know this for yourself, that people who can graduate with certain skills, simulation being one of them, can command up to 10% higher in their starting salary when they go into work. So it's an opportunity you really want to take advantage of. And just learning simulation to show yourself as valuable to your future employers or in the company that you want to start. So if you have any questions, please reach out to me. You can get my contact details through the IMechE, and you have up until October. And like I said, even if you don't win the challenge, get involved in it. Use it to show to your future employer. Use it to show to anyone that you have the skills and you are valuable going forward. You are valuable now, but you know what I mean, that you have the skills to take your company even further. Thank you very much, Dominic. That's it.
Thank you, Bridget. This is a slide that just shows everyone that has been working really hard at the back end of the design challenge. This is our committee members and myself as the operations project lead, and you've got Davide as the chair who's also at this meeting. So next up is our Q&A section. So please drop your questions into the Q&A box and we'll attempt to answer them from there.
Jonathan, if I can answer, please.
Thank you, Davide. Not in the mood for typing this afternoon. So I've got two questions, actually, one for yourself, Davide, and one for Bridget. Both relate to the submission deadlines that have been mentioned in your presentation. Also, thank you both for your presentations. Very, very, very helpful. I'll ask my question to you, Davide, first, and it relates to the main submission point on the Friday, the 3rd of October. Your slide said that submissions need to be made by Friday, the 3rd of October. Can we just clarify what exactly that means? Is that effectively the deadline of 23:59 on Friday, the 3rd of October?
Yeah, that is a bit of stretch. We recommend the end of play, so we recommend people to spare some time to go out and have a walk and have a nice refreshing drink at the end of the week. But yes, if you stick to the letter of the law, it's 23:59 of Friday, and that will be considered as a full submission.
I wouldn't advocate working to that time on a Friday either, but thank you for the clarification. Bridget, related to that, you mentioned that the submission point for the ANSYS simulation challenge is the same as the main submission, but on your slide, I did notice that it said the 1st of October. Can you just confirm that that is the 3rd of October as well?
Dominic, I'm going to ask you to check that for me. So it is the same date, I believe. Whatever. Yes, that is.
Yes, it is the same date. I just previously communicated the 1st to the teams and didn't want to add further confusion. But the earlier the better. And I kind of wanted to give Bridget a chance to have a look at the presentations before the 3rd, because there will be a lot of them coming in. So I wanted to kind of give her an opportunity to do so. So anytime, just as long as you do it before the deadline, it's fantastic.
So ideally the 1st, but the firm deadline is again 23:59 on Friday the 3rd. Have I understood that correctly?
Yes, please. That will be ideal.
Thank you thank you both very much again.
Thank you.
Please, in the meantime, so between now and October, understanding that in a few weeks there will start a holiday season, so we may delay coming back to you. Please do not hesitate to reach out to the design challenge or any other email of people that you have within over there to ask for questions, to ask for clarification, to submit ideas and all those kind of things. We really, really like to come back to you within reasonable time and have open this conversation. Most of the question will go openly on the design challenge Q&A section so that everybody will see which question was raised and what was the answer. We'll try to depersonalize it, so there will not be written who asked the question and what were the details, but we'll try to make available all those resources to every team so that all the team will have the opportunity to compete on a plain equal and level field overall for you. Yes, we have a Prakash, I believe, asking a question. Okay, so I have Prakash. Did you ask? Were you raising your hand, or it was your question that you raised in the Q&A?
It was the question I asked in the Q&A.
Okay, so the design challenge team will formalize the recording for this, put it on the website, and at the same time they will send out the link to the video. They will send out as well all the slide pack and any other information. I have a question from Orien. In terms of design excellence, will be great on marking a car that could be manufactured to an industrial extent, including being sold to a customer. Could you detail the criteria for the design tank's excellence, appearance, and attractability for customer, included being manufacturable to a larger scale? Very good one. Normally, for the design excellence, we have a schematic scorecard that look very, very similar to the peer review. So the concept that will be graded are exactly the same as the peer review. The difference is that it will be scored by a member of the industry that will be present during our event. They will try to score them against their personal experience and all the other vehicles that are available there. So always try to be mindful of, will I be able to build this easily, scale it up easily? Other little comments that may be part of the evaluation are bill of materials. Imagine that you have a limit of budget of £50 and you present your IMechE bill of material coming out at £49.90. That will be considered a little bit too risky because possibly cost will go up while you industrialize. If instead you come out with a design where over an allowed budget of £50, you declare that you reach only £45, that will give you a 10% confidence that your project will not creep as soon as you are going up in value. These are just examples of how it could be scored. And again, it depends on which will be the person appointed there and overall the competing teams. But there are some specific criteria that will be met over there.
Any other questions, guys? Please drop them in the Q&A box or raise your hands. Okay, looks like we've come to an end then. Davide and Bridget, thank you so much for your time. Thank you so much for presenting. I will edit this webinar and I'll put it on the website and I'll send it out to all of our attendees and our finalists. Any questions at all, guys, please feel free to email either the DC Judges inbox or Design Challenge inbox. And, you know, good luck with everything and we'll see you in October. Thanks, everybody. Bye.
Thanks, Dominique. Bye, Davide, everyone.
Thank you.